Welcome to IB360. In this video, we are going to solve the ninth problem. This problem is basically a normal problem where we need to find out this type of equation, and after putting the values of t, almost all the answers we will get. So let's start to solve the problem. So the first question is, in an experiment, a number of fruit flies are placed in a container. The population of fruit flies P increases and can be modeled by the function Pt is equals to 12 into 3 to the power 0.498t, where t is greater than equals to 0. Where t is the number of days since the fruit flies were placed in the container, and the A number question is find the number of fruit flies which were placed in the container. So ultimately in this question it is asked that you need to find out Pt at t equals to 0. So at the first time, how many fruit flies were there in the container? We need to find out that in this particular question. So ultimately we need to find out P of 0. This is equals to 12 into 3 to the power 0.498, and here the value of t will be 0. So anything to the power 0, anything to the power 0 is basically 1. So this complete term will become 1. So 12 into 1 is equals to 12. So which were placed in the container, find the number of fruit flies. So the number of fruit flies were 12. Those were placed in the container. So this is the answer for the first part. Now the second part. Find the number of fruit flies that are in the container after t days, after 6 days. So here t will be is equals to 6. This is a very simple problem. As I have told already, by using the number of t, or by placing the value of t, you will find many type of answer from this particular question. So in this question, it has been asked, we need to find out number of fruit flies in uh, in the container after 6 days. So we are finding, so here it will be P of 6 is equals to 12 into 3 to the power 0.498 into, it will be multiplied by 6 because this is the function. So you are allowed to use calculator in this particular question booklet, so you can use that, and after using that you will get the answer through to be 319.757. But try to figure out whatever we are trying to find out. So basically we are trying to find out the number of fruit flies, so that cannot be in fraction, so we need to approximate that. So after approximating, you will get the answer to be 320. So there in the container after 6 days, number of fruit flies will be 320. So this is the answer of the second part. This was also again a simple part. Now the third part. Okay, in the third part, the maximum capacity of the container is 8,000 fruit flies. Find the number of days until the container reaches its maximum capacity. So as you can see, P of t is basically the number of fruit flies. So here P of t is given as 8,000. So 8,000 is equals to 12 into 3 to the power 0.498 t. So this, here we need to find out t. In how many days the container will be filled up by 8,000 fruit flies. So for that we can do this in this way, by 12 is equals to 3 to the power 0.498 t. So here we can use log in both the cases. So log, here base is e, so log 8,000 by 12 is equals to log 3 to the power 0.498 t. Again the base is e here. So we will not write base e all the time. This is the natural logarithm, Napier logarithm. So basically the base will be e here. So according to the log formula, log a to the power b is basically equals to b log a. So we will use this formula here. We will find out the value. So log 8,000 by 12 is equals to 4980 log 3. So in calculator you can find out these two values, and after that you will calculate. Just this will be one value, this will be one value, this you can find out from your calculator. So after that the t value will be approximately, t value will be 11.888, and after approximation t value is 11.9. So this is the answer, 11.9. The unit will be in days. So in 11.9 days, the container will be filled up by 8,000 fruit flies. So this is the answer for the last part. Okay, so thank you for watching IB360. In next video, we will cover the next question. Thank you.